Hello, welcome to the Golden Configuration Catalyst in TMF 2018 at Nice, France. So this is a solution which we have put together to improve the fault tolerance of NFV based systems. So we'll spend some time to go over the solution that we have put together here for Catalyst 2018. So Verizon is the champion of this program, and Infosys is the lead systems integrator. And from Nuviso Networks, we have contributed the centralized config management system for the solution. So traditionally, when we are migrating from the physical network elements to the virtualized network elements, we are seeing a lot of benefits. But in addition to the benefits, we are also seeing a lot of operational challenges. So some of the key characteristics of NFV based systems we can see in this slide. So they are extremely agile. So to bring up a new network element into life usually takes of the order of a few minutes, as against weeks or months that will normally take with the physical network elements. Also, because of the virtual nature, they are also extremely dynamic. A specific virtual network function can either be grown or shrunk in response to the various events from the VNF. So because of the extremely agile and dynamic nature of the VNFs, we are also seeing that the probabilities of failures are also going up. Because of a number of events that needs to be handled, any failure, when it happens, the impact of the failure is also magnified by manyfold. See, for instance, in a physical network element, if a particular physical element fails, then the impact is localized only to the function of the physical element. Whereas in the case of a virtual environment, if a particular host which is hosting a number of VNF fails, it brings down the entire set of VNFs which are running on that host, right? So the failure impact is always magnified. Then in addition to these characteristics, there is also a lot of extra state that needs to be maintained with NFV based systems. And all these things need to be put together in such a way that any failure can be automatically handled and they are auto healed. So the scope of this catalyst mainly addresses the last two characteristics of any typical NFV system. I mean, we are proposing how the state maintenance can be automated and how the auto healing can be facilitated. So these are some of the challenges which we already discussed through the magnified impact of failures. And the other challenge is it always becomes very difficult to do a root cause analysis in the NFV based systems. And there are no specific standards that prescribe how such auto healing or like a state maintenance should happen in the VNF systems. Then the last additional challenge is there are a number of new life cycle stages that needs to be maintained for every element. So these are all some of the challenges. Now coming from an operator view, right? So what does a typical operator look for to run an NFV based system, right? So the first key need is how do they configure a network service independent of whether the underlying element is a physical or a virtual element, and more importantly, how do I baseline the configuration? So that is one of the key asks. Then the second key ask is how do we capture any changes in the configuration in real time? Because traditionally what happens is there will always be like a config management system, but it will snapshot configurations at defined periodicity, maybe like every 12 hours, every 24 hours, and it will take a full config snapshot from the network element. Whereas with VNF based systems, it is not only the core configuration that can keep changing, but the very VNF can also keep changing in terms of dynamically growing or shrinking in terms of capacity, right? So how do we keep track of all these config changes and get updates in a real-time basis? And then third, when a failure happens, how do we trigger auto heal sequences, right? So these are all some of the key asks from operators to keep NFV based systems functioning smoothly. And some of the additional drivers for this catalyst from our view are we did not find much standards that talk about state maintenance or how to do config maintenance in a centralized way. And then how do we build in scalability, right? I mean, like when we work with hundreds or thousands of VNFs, how do we make sure that the solution really scales, right? So these are all some of the things that we have addressed in this catalyst. Now I'd like to hand it over to my colleague Praveen, who will talk through the solution.
So in this particular solution, there are three main components that we have. One is the orchestrator. The orchestrator is the one which does the instantiation, and it is the one which pushes day 0 and day 1 configuration. And the second component is a configuration management system. We are using Novizo Interlude, and orchestrator is open source Mano. And apart from these two components, there is a third component, that is VNF and a microservice which is running over a VNF, which is triggering the change notification. So whenever there is a change, this is the microservice which is coming into picture, which triggers a notification to the configuration management system. And all the integrations that we have done, we have used TM Forum standard APIs, open APIs, which is to integrate both OSM with the configuration management system and microservice with the configuration management system. So as far as the flow is concerned, as described before, there are three main parts. One is the instantiation, and the second part is how the change is going to flow, and third part is how exactly a recovery is going to happen. Coming to first part, so as described before, the orchestrator is the one which is going to trigger the instantiation part, and once the instantiation is done, orchestrator is going to trigger a discovery function to the configuration management solution to discover the VNF. That is, this is where configuration management system gets to know that there is a VNF which is instantiated in the OpenStack. Once discovery is done by the configuration management system triggers the pushes the day 2 configuration, and this is where the model driven template based day 2 configuration is being recommended, where configuration management system is pushing a predefined template for that particular device type. So once that is actually pushed, this is where the first baseline is created in the golden configuration system. Coming to the second part, where when there is a configuration change that is happening on the VNF microservice is going to push the change onto the configuration management system. And once the change is notified, a rule engine, which is a policy driven rule engine, is going to decide when exactly a baseline needs to happen within the golden configuration store. So once the baseline is there, this baseline is the one which is used to do the recovery of that particular VNF. So this is how we are actually covering the three statements. That is, when we are talking about how exactly a configuration needs to happen, like this is where the model driven template based configuration is pushed. And the second part, microservice based change notification, that is a near real time configuration change notification that is done. And the third part, auto healing using the baseline configuration.